But the next talk will be by Mehdi Benna, and he will talk about the Lunar Environment Monitoring Station, or LEMS.
Hi, do you hear me?
Yes, we can. I can.
Oh, okay, perfect. So I would like to give you a little bit of an overview about about LEMS. LEMS, as you said, stands for the Lunar Environment Monitoring Station. It's a selected instrument suite by Dolly that it's in the end of the second year of development. Next. So LEMS, in a nutshell, LEMS is a compact, autonomous, and self-sustaining instrument package that was designed to enable long-term in situ monitoring of the lunar environment for a nominal duration of 2 years from its deployment on the surface of the moon. LEMS does not require resources to operate, so it carries all the needed resources from power, thermal, digital control, and communication that's required for these instruments to operate. And the only requirement for it to function on the surface of the moon is that you get it there. So we do have a requirement for deployments on the surface, whether through by a robotic lander or by a crewed mission. But once you put it on the surface, it deploys itself and operates for the nominal duration of at least 2 years. In its first version, the station is baseline to carry two instruments, a quadruple mass spectrometer and a seismometer. The mass spec will be tasked with collecting daily measurements of exospheric composition. So the station operate the mass specs once every 20 Earth hours, and for about 20 minutes that allow us to sample the ambient exosphere, and then we do that again 24 hours after for about 30 times during a lunar lunation. The seismometer, however, operate continuously and basically will be always listening to the seismic activities of the moon, and the goal there is to constrain the structure and of the lunar interior. We have a version called the LEMS Plus, which what we actually propose for the Prism RFI, which includes a micrometeoroid impact detector and a solar wind ion analyzer. And the goal here is to have a handle on all the processes that act on the lunar exosphere. So we can, by monitoring the inputs to the surface, we can constrain the response of the observed response of the exosphere. Next. The LEMS package is designed to address decadal survey goals, and more specifically the state of the lunar exosphere by constraining its composition and expanding the inventory of known volatiles at the surface, both organic and inorganic.
2 minutes left.
Yep. And then look at its dynamics in response to processes like tidal driven outgassing, micrometeoroid, or transport and surface interaction. Having a seismometer opens up a very wide opens up widely open a new line of investigation related to the structure of the lunar interior. It serves to constrain the lunar exosphere, but also should you have multiple of these stations on the surface, you can do constrain the structure of the lunar interior. Next. In addition to the science objectives, Elem Sub, it's a technical demo. And the idea behind it is to augment the current capability of the CLIPS landers by guarding the CLIPSes from having to survive beyond a few days on the surface of the moon. LEMS will be able to carry any instrumentation that requires long-term survival. It provides the thermal power communication resources for sensors that require long-term operations. And finally, it provides a simple and standalone interface to the CLIPS. All what we need, we joke about it, but reality, all what we need is 4 bolts to the deck of a lander. And so it makes a one-stop shop for instruments for sensors that require custom interfaces and long-duration operation. Next. It also feeds into the goals of operation by crewed mission by providing a single, easy-to-handle package. Astronauts have just to take the package itself, put it on the surface, walk away. Once it activates itself, it will operate all the instruments. Next. So here's a very quick table of the specification. The specifications of the current DALI design. So it gives you the full mass of the station, its power, comm, and capabilities. The mass spectrometers is in line with the performance we designed for the LADI mission and the MAVEN mission. It gives us a 13 order of magnitude density range for exosphere measurements. The seismometer, it's
You're 30 seconds over time, Mehdi.
Yep, it's a wideband seismometer. Next. I'm gonna just leave you with a picture right now. We are about to push the prototypes into a thermal vac chamber for testing, and you can see what it looks like and its size relative to a human being. That's all.
All right, thank you so much, Mehdi.